Welcome to another interesting session with Emmy. We'll take up examination style question and understand how do we solve such problems. You may join my classes, gain confidence, connect learnings, and get ready for future. Share the gift of education. Let us now enjoy the lesson with Emmy. And another question. Involves trigonometric function right there. So, can you tell me? Read the question, then we'll begin.
Read the whole question. Learn my lesson.
Yes.
Okay, so figure 5 shows a sketch of the curve with the equation y equals f of x, where f of x is 4 sine 2x over e to the power of root x minus 1. Where x is in between 0 and pi, both included. So the curve has a maximum turning point at P and a minimum turning point at Q, as shown in figure 5. Part A, show that the x-coordinates of point P and Q are the solutions of the equation tan 2x equals root 2. Then part B, using your answer, part A, find the x-coordinate of the minimum turning point on the curve with equation y equals f of 2x and y equals 3 minus 2 of f of x.
Got it.
Like translations and transformations.
Okay. So the important key point here is, again, the weightage is 4, 4, very good. At least you know the answer of part A.
Yeah.
Let us say by any chance you're not able to solve part A. You know tan 2x equals to 2 is the solution, and you can actually do part B without even solving part A. So remember that part. So even if you do not get part A, you can still get 4 marks of part B by using this as your given
answer, right?
So now let's try to get the answer, right? So that's very important to understand. So it says the curve has a maximum turning point at P and minimum turning point at Q. That means their derivatives are 0 at those 2 points. So that the x coordinates of P and Q are the solutions of this equation, correct? So let's find the solutions of this equation tan 2x.
That's how faster.
Yeah, why not? Why not? So tan 2x. They have also given you that x is between pi and 0. Is that clear to you?
So 2x domain will change.
So 2x domain will be between 2 pi and
0.
Tan 2x is equal to square root 2, and that means you can look into, you can find what, let's say this is alpha, right? So let's think about it. So tan 2x is positive, right? So that means you're looking for solutions in quadrant 1 and in quadrant 3. Is it clear to you?
Yeah. So I just used the calculator to find the alpha angle.
Yeah. So
getting 0.
Alpha is how much for you?
0.955. Before SF or 3 is fine.
So, and then add pi to it?
4.096.
So you find both the angles. Now they're saying the curve has maximum turning points at P and minimum at Q as shown in the figure. Show that the x coordinate of point P and Q are same, are the solutions of this equation tan 2x equals to square root 2. So at least we know what we need to show. You get the idea?
Yeah, but sir, just a quick thing. So you know the 2 angles that we just found, those are the values for 2x. So do we need to find x?
Yeah, you need to find x. So, we have got the value of 2x equals to, so this is alpha. So we have alpha is equals to this, you're right. So 2x is equals to 0.955. So x is equals to half of this, right? So
I'll just quickly do it. 0.477.
This is x1, and then x2 is what? 2.013.
Yeah.
So you have both answers on this side. So at least you know what you are expecting. You get the idea?
Yeah.
Now, this equation, let's find the derivative. To find the derivative, pardon?
Sorry, sir. If you just, because of when you do on the calculator, it's 2.048. I know you did in your head, but still, just for accuracy, maybe.
The second one is 2.048.
48, yeah.
Okay, let me do it. Doesn't. Okay, that's fine. Very good. So for this function, so what is the derivative of the function? Tell me.
So I used the quotient rule.
Yes, you use the quotient rule. So
So
square
I
of
did,
this.
so we did e to the power of root 2x minus 1. Well, that would be whole squared at the bottom, but I mean on the top as numerator. So we do e to the power of root 2x minus 1 times 8 cos 2x. So I got that from taking out the 2 and timesing, and then sine 2x when you differentiate is cos 2x.
And then multiplying by 2, right?
And then multiply by 2, yeah. And then
So let me
that
multiply
whole
it
bracket
minus.
minus 4 sine 2x times root 2 e to the power of root 2x plus 1.
Okay, times derivative of this is root 2, right? E to the power of root 2 x minus 1. Correct?
That doesn't change, yeah.
That is it.
I
Now,
didn't bother
turning point means
simplifying,
this is equal to 0, right?
yeah, because of that, yeah.
Correct. So when you equate this to 0, e to the power of root 2 x minus 1 is a common factor, right?
Yeah.
And that will never be 0. That can be 0, right? That can be 0. We can just put this here. So we can now see what is the numerator. So I have less space here. We have e to the power of root 2 x minus 1 is one common factor, correct? Then we have 4 is also a common factor. The other factor is square root 2, right? So 4 is also a common factor. So what we are having here is 2 times cos 2x.
Yep. Minus
Sine 2x. And what is the square root 2, right?
root 2 sine 2x. Yeah.
Equals to 0. So these are the two factors, and that gives you solutions. And we know x is between 0 to 2 pi. So exponential equation will never be 0. It is always positive, right?
Yep.
Only inside part will be 0. And we know this is tan 2x, right?
And 2x equals 2
So we
over
have,
root 2.
yeah. So when we equate and divide, that means 2 cos 2x minus square root 2 sine 2x equals to 0, right? And that gives you sine square root 2 sine 2x equals to 2 cos 2x. So dividing by cos 2x, we get, let's divide by cos 2x, right?
Yeah.
So we get tan 2x equals to 2 divided by square root 2, which is square root 2, correct? So actually we get the solution directly. We don't even have to find the point, right?
Right. Yeah.
So we do get this result, which is show that the x coordinates of point P and Q are the solutions of this equation. Yes, they are. Perfect. Now let's look into part B.
So using your answer to part A, find the x coordinate of the minimum turning point on the curve with equation y equals f of 2x. Oh, sorry, and y equals 3 minus 2 of f of x.
Okay. So first thing, find the coordinate points because they change the function. Do you see that? Using your answer to part A, find x coordinate of the minimum turning point on the curve with minimum is this turning point, right? Yeah. Using your answer part A, find the x coordinate of minimum turning point on the curve with the equation that, and you know the equation is not f of x, f of 2x. You get, so it has been horizontally stretched by a factor of half. Get the idea?
Right. Yeah.
Now we found that the x coordinates are these two values. So these two values are required. You get the idea. It is not a wasted effort. And from here, we know that the point 2, which is on right side, which is 2.048, whatever you said, right? So the x coordinate value will be what? Will be, it is horizontally compressed by a factor of half. So it will be half of this value of 2.048. You understand?
So 1.024.
So that is the answer for part 1. You get the idea?
Yeah.
Similarly, for the second one, y equals to 3 minus 2 times f of x. So
I mean, I kind of know, but just so I can see roughly.
So equation, this one we are talking about, and the confusion was minimum, right? So when you reflect, we have y equals to 3 minus 2 times f of x, right? So that means there is a reflection of this curve. And so this point, which was maximum, now becomes the minimum because it comes here, right? So that becomes the point P dash is the point, and therefore this value of x is what we have to look for, which is 0.0478. Is that clear to you?
Yeah, but that was only for the graph of
Second one.
flipping it.
Yeah. In the first one, there's no flipping, and therefore we are looking at point Q, and that was half of that because of horizontal transfer. Very beautiful question, where they have also combined transformations with the question, correct?
Yeah.
And
Yeah.
mind it, we actually did the derivative and solved the question on the right-hand side.
Mhm.
It was not a waste of effort.
No.
Ultimately, it helped us to get the last 4 marks. You get the idea?
Yeah, and
Both points
also
were part of that question.
yeah. So both points were calculated. Because so the moment you see it, just to avoid wasting time, just go straight into it and just start already. Don't like start reading and analyzing for ages and ages because time's going. So just at least get something down on the paper.
Yeah.
For things you know that you will later on use.
Yes.
Perfect.
Okay. So once you do this work, then you can say, well, part A solution is this, part B solution is that, correct? And
Yeah.
you got all this reference right there to put it.
Perfect. Yeah.
Okay, great. Good questions. Let's see the next question now.